Hello everyone. In this video we are going to talk about recursive counting. So what is recursive counting? We've actually pretty much seen this before except for the counting part of it. Basically, we're doing recursive formulas again. So you remember seeing sequences like a1 equals 2 and then the nth term in our sequence is say 3 times the previous term, the n minus 1th term in our sequence. Right, then we could just write, okay, we've got 2, then we multiply by 3. 6, we multiply that one by 3 to get the next. 18, 54, and so on, right? This was a recursive formula. So there, we didn't really have a context other than just find a formula for a sequence. Here, we're just going to be applying it specifically to counting. So for some examples that we're going to talk about, these are counting problems that depend on n, right? So first one we're going to look at is an, where this is the number of n-digit numbers with no zero, like none of the digits are zero, and bn, which are the number of ways to tile a 2 by n board with dominoes. So there, right, the length of the board is increasing, it depends on n, and the first one, just the length of the number, how many digits it has, depends on n, and so of course the number of ways to count this thing will change, and we want to find a formula depending on, counting one less than that. Okay, so let's start by trying to find this recursive formula for the number of n-digit numbers with no zero. So I think it's helpful to just start with a few examples, right? So the first one, if we just have one digit, right, so n equals 1, then we have 9 choices, right? We can do 1 through 9, can't have a 0. If n equals 2, then, well, to have a 2-digit number, this first one can't be 0 anyway, so we would have 9 options. And then the second one also cannot be a 0, so we'd have 9 times 9. And you can probably get a general formula pretty quickly from this as well, that it's just going to be 9 to the n. But we can also break it into cases recursively, where we filled in this first digit, it was not 0, and then we get a length n minus 1 number after that. And if we already know how to count n minus 1 digit numbers with no 0, then all we had to do is multiply our previous thing by 9, right? So if we look more generally, if I've got a whole bunch of digits here, then if this is length n overall, these ones after the first one is length n minus 1, so we have 9 options for our first, and then this would be a sub n minus 1 ways to count how many n minus 1 digit numbers there are. And so here we know that a1 is 9 because, well, we just calculated that one. And then an is 9 times an minus 1. And so this would be a recursive formula. So why would we ever prefer this over like a closed formula? Because it's also, in this case, an is 9 to the n. In this case, both are pretty easy, but often if you're, programming something, it can be nice to just kind of run through loops and say, okay, we've added one more case, and so we nest this with the previous one, and we just say, okay, yeah, we multiply what we already had entered in the computer by 9, and then we're done. So it kind of depends on the context, but having different perspectives to look at it can be very useful. Okay, so now let's look at one where it's probably going to be a little more clear why recursive is easier here. So we want number of ways to cover a 2 by n board with dominoes. So a 2 by n board, that just means, we've got something that's pretty long maybe here. So I'll just put some dot, dot, dots in there, and we just have basically like a top and bottom, or 2 rows and n columns, right? And then dominoes are just 2 by 1 things, but we can also lie them horizontally, and so we have kind of 2 options that we can use to cover these. So this is one where I think it's very helpful to, again, just draw pictures, right? So let's start with n equals 1. So there we would have a 2 by 1 board. So it looks like this, and I'm just going to use my dominoes as like horizontal lines or vertical lines. So here we have one option, right? We have to lie it vertically. That's the only way, and then it covers it, right? So there's one way to do this. So B1 is 1. What if we have two things because I'm not necessarily sure if I've gleaned any real information there. Here we have two options, right? And it kind of depends on whether we lie our first tile vertically or horizontally. So we can do vertically, in which case the other one has to be vertical, or we can do horizontal, in which case the other one has to be horizontal. And so there are two ways to do this. So B2 is equal to 2. And this tells me a little bit more about how this is going to work in general. So if we have some long board, I really need to think about how am I going to lie this first tile, right? Because if I lie the first tile vertically, now I am left with a 2 by n minus 1 board. And so then it's just, okay, how many ways are there to fill in this? And so this would be exactly b n minus 1 ways, because it's just filling in the remaining n minus 1. But I didn't have to lie that first one vertically, right? I could have laid it horizontally, in which case what would happen? Well, I would have to fill in this other one horizontally below it, and then suddenly I have a 2 by n minus 2 board remaining, and I know how many ways to count that, right? That's going to be b n minus 2. And so since these are my only two options really, right, I lie it either vertically or horizontally to start, this means that bn is bn minus 1 plus bn minus 2. And if it depends on the two previous, then we really need both of our first two cases as base cases. So here we know that b1 is 1 and b2 is 2. And so this would be a recursive formula for that. And you can see probably that it's a little bit harder here to come up with a closed formula. It's not really clear how to like count these things in general. We'd have to go out a decent ways maybe to figure out the pattern, but this is just the Fibonacci sequence basically, which does not have a very nice closed formula. So this is kind of the preferred method in this case. Okay, and so for your exercise, we're going to let Cn be the sequence that describes the number of ways to arrange a binary sequence of length n. So remember, binary just means your options are 0 or 1 in each slot. And so I want you to find a recursive formula for Cn, not a closed formula, and explain how you got it. Thank you for watching.